Here you're asked to find the value for the sample mean such that it corresponds to a certain percentile rank. In this case, it has to correspond to the 5th percentile, so that the value of the mean, the sample mean, should be such that 5% of the time the scores under the distribution fall below that sample mean. Okay, so the way to do that, or the way to obtain this sample mean, is to find the z-score that corresponds to the 5th percentile. So if 5% of the sample means fall below this value, the area under the distribution that's shaded should be equal to 0.05. The z value you have for that is given here. You have to solve for x given this z value. So I'm going to do that on Excel. Let's see. Why? Okay, so the mu that we have is 26.6. Standard deviation is 26.08. N is equal to 57 because that's how large the sample sizes are. The z that we just got is minus 1.6449. The way I got this is by multiplying the z-score by sigma divided by the square root of n. So whatever sigma divided by the square root of n gives you, multiply that by z and add to that the value of mu. Okay, so once you do it, the sample mean you get is 20.91789, which you have to round to 2 decimal places. It'll give you 20.92. Okay, 20.92. Okay, so now we're moving on to problem 1 of 3. This is a psychologist who's interested in paranormal experience. In this case, what you have is a psychologist who tests 1,826 individuals who believe they have paranormal abilities. The test is that they have to predict the second card from the bottom of a deck of cards, and that probability is actually equal to 0.019231, because they're if you're in fact no better than chance, because it's there are 52 distinct cards in the deck and you're picking one out of 52. Now, once these subjects come in, the psychologist finds that roughly 0.017 or 17% of them, or sorry, 1.7% of them correctly identify the card. Okay, and he wants to know if there's any evidence that this population, and they're undergraduates, has the ability to predict the outcome of a random event. You're supposed to use the alpha equal to 0.01. How many groups are there in this experiment? There's a single group of undergraduates. This is a naturally defined experiment because the volunteers sort of show up themselves and believe they have extrasensory perception. You have to put in naturally defined. You can't copy. If you copy this and paste it, it'll be wrong. Other measures independent. Each person is tested independently, so I'm going to say yes. Are the measures continuous or binary? Each person will either guess correctly or incorrectly, so they are binary. Okay. Can this be analyzed as a binomial experiment? In other words, does it meet the criteria? Can the outcomes be classified into only two mutually exclusive and exhaustive outcomes? Yes, you either get it or you don't. The outcomes are independent. The probability of success is constant from trial to trial. That is, there's nothing that tells us one person should be better than another person when it comes to extrasensory perception. So the answer is yes, all the conditions are met. Is there reason to believe that the proportion of people, p hat, who correctly identify the second card from the bottom will be normally distributed? Yes. Now, I skipped this whole bit here, but it says that even with a binomial experiment, if the number of measurements is large enough, and here we're interested in over almost 2,000 people, so that's very large, the number of successes divided by n, so y divided by n, which gives you p hat, will be normally distributed. So the answer is yes. Because this is quite large, we know that it'll be normally distributed. Do we know the standard deviation of p hat when the null hypothesis is true? The standard deviation is given by the square root of p, probability of success, times q, 1 minus the probability of success or the probability of failure, divided by n. So yes, we do know, we have all the information we need to compute this. So I'm going to write yes. What is the value of the probability of success under the null hypothesis? It's equal to getting guessing the card correctly by chance. And that number is given to you here. Just going to copy it and paste it. Which research hypothesis is appropriate? Well, you're predicting that if they do have extrasensory perception, they're going to be better than chance. So it's going to be B. Enter the value of the test statistic p hat. So that's going to be equal to the number of successes in this sample divided by the number of trials. In this case, you don't have to compute it. You're given that value. It's p hat in your sample. What is the standard deviation of p hat when h null is true? Round to 6 decimal places. Again, I'm going to do this on Excel. Okay, so when the null is true, what is the value of or the probability of success? It's this value. Okay, that's pH null. P hat, we just entered it into Mathematica. That's this value. Q hat, or the probability, not Q hat, the probability of failure is going to be 1 minus the value in S1, which is the probability of success. So that's already computed here. The sample size, I'm just going to scroll up. I forget what it was, 18 something. 1826. Okay, and this is the standard deviation. Again, it's the square root of the probability of success under the null times the probability of failure under the null divided by n. Okay, it's just, I just followed the formula I was given here, right here. Square root of p times q times n. Okay, and now let's see what I was being asked here. The standard deviation, so this value. I have to round it up to 6 decimal places. So that's 4 here, and that should be correct. Enter the z-score equivalent of p hat. So again, I'm using this formula here. Where is it? It's right here. So z is equal to p hat, which is the proportion of successes in your own experiment minus the proportion of successes you'd expect if, or the probability of success if the null is true, which is 1 over 52, divided by the standard deviation, which we just computed. So I've done this on Excel, and it's automatically computed this for me. The z-score is equal to minus 0.7013261. I'm asked to round this up to 2 decimal places, so it's minus 0.70. Okay, enter the z value corresponding to the lower boundary of the acceptance region. In order for me to reject the null, a higher proportion of people than I would expect by chance should get this, should guess the card correctly. So my rejection region is in the upper tail of the z distribution, which means that the z-score corresponding to the lower boundary of the acceptance region is essentially, it's in theory, it's minus infinity. So I'm just going to type in minus infinity, and that should be correct. The z value corresponding to the upper boundary of the acceptance region. You were told to use alpha 0.01. So it has to be a z-score such that the non-shaded area is equal to 0.01. The shaded area will be equal to 0.99. Okay, so it's, and you have to round it up to 4 decimal, 2.3263. 2.3263.